Hello, this is the first of my algebra lesson videos. Here I give you a brief description of what algebra is, how it can help us, and how it is useful in daily life. Why do we need to learn algebra? The purpose and scope of algebraic concepts are fundamental to understanding the role of algebra in mathematics and its applications in various fields. Algebra is a branch of mathematics that deals with symbols and the rules for manipulating those symbols. Algebra encompasses problem solving, modeling relationships, generalization, abstraction, logical reasoning, basic arithmetic operations, expressions and equations, linear and nonlinear relationships, systems of equations, inequalities, polynomials and factoring, functions, exponents and radicals, matrices and determinants, abstract algebra. I will explain all these topics. Hang tight. Problem solving. Algebra provides a systematic method for solving mathematical problems. It allows the representation and solution of problems using symbols and equations. Example. Suppose you have $100 and want to save a certain amount each month to have a savings of $400. You can use algebra to represent this situation with an equation like 100 plus 12x equals 400. Where 100 is the initial amount, x is the amount saved per month, and 400 is the total amount at the end of the year. You can now solve for x to find how much to save per month. Modeling relationships. Algebraic expressions and equations are used to model and describe relationships between different quantities. This is particularly important in various scientific and engineering fields. Example. In physics, algebra can be used to model the relationship between distance, time, and speed using the equation d equals vt, where d is the distance, v is the speed, and t is the time. Generalization. Algebra allows for the generalization of patterns and relationships. Instead of solving specific instances of a problem, algebraic techniques can be applied to solve a whole class of similar problems. Example. Algebra allows us to generalize and ask, find two numbers such that they add up to 20. We can then write a plus b equals 20. Where a and b are two random numbers that we can find through simultaneous equations. More on simultaneous equations in another video. Abstraction. Algebra involves working with variables and symbols, allowing mathematicians to abstract common features and patterns, making it easier to express and analyze mathematical relationships. Example. Algebraic expressions like 2x plus 3 represent a general concept, letting us work with any value of x. Logical reasoning. Algebra encourages logical thinking and reasoning. The process of solving equations and inequalities involves logical steps and deductions. Example, solving an equation like 2x minus 5 is equal to 7. Involves logical steps such as isolating x by adding 5 to both sides and then dividing by 2, leading to x equals 6. Basic arithmetic operations. Example. 3x minus 2. Involves basic arithmetic operations with a variable, extending the concept of subtraction to algebra. Expressions and equations. Example. 4 times plus 2 is equal to 10. Which is a linear equation, more on linear equations in another video. Linear and nonlinear relationships. Example. y equals 2x minus 4 represents a linear relationship, while y equals x squared is a nonlinear equation. A linear equation is an equation that is satisfied by only one value of the variable, whereas a nonlinear equation can be satisfied by multiple values of the variable. In the first equation, x can only be 2 if y equals 4. In the second equation, x can take on the values 2 and minus 2 if y equals 4. Systems of equations. Example. Solving the system of two or more equations like 2x plus 3y equals 12. For x minus 2y equals 8. Allows you to solve for both variables. Inequalities. Example. 2x plus 4 greater than 6 represents an inequality, where x can take values greater than 1 for the inequality to be true. Polynomials and factoring. Example. Factoring the quadratic. X squared minus 4 can be factored into x plus 2 times x minus 2. Functions. Example. F of x equals 3x plus 5. Defines a linear function, where x is the input and f of x is the output. Exponents and radicals. Example. 2 cubed is a cubic exponentiation exponent is 3. This is 2 times 2 times 2. Square root of 9 equals plus or minus 3, where the root is also called a radical. Matrices and determinants. Example. In linear algebra, a system of linear equations can be represented as a matrix equation. Capital A times x equals capital B. More on matrices and determinants in another video. Abstract algebra. Example. Abstract algebra explores structures like groups, where operations follow specific rules. For instance, the integers with addition form a group. I hope you were able to follow along and get an idea of what algebra can help us figure out different values. I know this video was just about theory and not very exciting, but stay tuned. Later videos will be problem solvers, and be more interesting. Well, please like, share and subscribe to help this channel grow. See you on the next one.